Hello everyone, in this video we are going to learn how to interpret an ABG. So before starting we need to know certain parameters that we will be needing to decode the ABG, and they are pH, PCO2 and bicarbonate. So the normal blood pH is in between 7.35 to 7.45. The normal PCO2 is in between 35 to 45 mm of mercury, and the normal bicarbonate is in between 22 to 26 millimole per liter. The PCO2 values, it denotes the respiratory status of the body, and the bicarbonate value, it denotes the metabolic status of the body. And for the sake of simplicity and for the calculation, we will be taking the average of all the three values, that is 7.40 for the pH, 40 for PCO2 and 24 for the bicarbonate. And you do not need to mug up these values because as you can see here, the pH is in between 7.35 to 7.45, and this 35 to 45 is also the PCO2 value, and just remember the 22 to 26. Now coming to ABG analysis. So step 1, check if it is acidosis or alkalosis. So I told you that we will be taking the average of the pH, that is 7.4. If the pH is less than 7.4, then it means that we are dealing with acidosis. And if the pH is greater than 7.4, then we are dealing with alkalosis. Once we are done with the acidosis and alkalosis part, then we have to move to step 2, and that is we have to check the primary defect, that it is whether the metabolic defect or the respiratory defect. So I told you that SCO3 or the bicarbonate is dealing with the metabolic part and PCO2 with the respiratory part. So in the acidosis, bicarbonate decreases. In which kind of acidosis it will be decreasing? It will be decreasing in the metabolic acidosis. And in acidosis, PCO2 increases. In which kind of acidosis? It is the respiratory acidosis. Similarly, if I talk about alkalosis, the bicarbonate increases, that is greater than 24, in the metabolic alkalosis, and the PCO2 decreases less than 40 in case of respiratory alkalosis. So till this step we came to know that whether it is acidosis or alkalosis and what kind of the defect it is, whether metabolic or respiratory. So once it is done, then we need to know that whether there is compensation or not. It means that if there is defect in the metabolic part, then the respiratory part will compensate and vice versa. So we will be discussing about each compensation one by one. So starting with the metabolic acidosis. So in the metabolic acidosis, bicarbonate decreases, isn't it? So for every 1 millimole per liter decrease in the bicarbonate, the PCO2 value has to fall by 1.2 mm of mercury. And mind that in the compensation part, both the values will go hand in hand. That is, if the bicarbonate decreases, then PCO2 value also has to decrease. Okay, so let me illustrate it for you. Suppose we know that the normal bicarbonate value is 24, isn't it? Suppose in the acidosis it has fall to 19. So there is fall of 5. So PCO2 has to fall by 1.2 into 5, that is 6. So the normal PCO2 value is equal to 40, and if it falls by 6, then it will be 34. So if in the question the value of the PCO2 is 34, then you can say that it is metabolic acidosis, that is compensated. And if the value given is only 40, then you can say that it is uncompensated. And any value in between this 34 and 40, it will be partially compensated. Alright. Now talking about the metabolic alkalosis, for every 1 millimole increase in the bicarbonate, PCO2 value will increase by 0.7 mm of mercury. Same thing for the respiratory acidosis. Here in the acidosis part, the PCO2 value will increase, isn't it? And for every 10 mm of mercury, the bicarbonate value has to increase by 1 millimole per liter. Okay, here we are saying the value as 10. There the increase or decrease was in 1 unit. Okay, and in case of respiratory alkalosis, for every 10 mm mercury decrease in the PCO2, bicarbonate value has to decrease by 2 millimole per liter. And these two conditions are for the acute cases. Okay, and if we are talking about the chronic case, then the increase or decrease has to be by 4 for the chronic cases respectively, for both the respiratory acidosis and alkalosis. Alright, now we are done with step 3. Now coming to the step 4, if in the question you came to know that we are dealing with the metabolic acidosis, then we have to find the anion gap. So what is this anion gap? Anion gap is equal to sodium minus chloride plus bicarbonate. So sodium, it is the cation, and here it is the anion. So in the body, cation should be equal to anion, isn't it? But in the body there are certain anions that is not calculated routinely, like the phosphate. Then the albumin also has the negative charge, and because of this difference there is some anion gap, and this anion gap is in between 8 to 12 milliequivalent per liter. But if there is increase in anion gap, that if it is greater than 12, then it is known as high anion gap metabolic acidosis, or HAGMA. It is because in the acidosis bicarbonate decreases, so to compensate it the chloride increases. But if in the body there are certain toxins that produces anions, like the lactic acidosis or the ethylene glycol, so in these cases the anions are produced, and that is why the chloride doesn't increase, and henceforth the anion gap increases, and it is known as HAGMA. To know that it is high anion gap metabolic acidosis. So the next step, that is step 5, will be to calculate the delta ratio. The delta ratio is anion gap minus normal anion gap, that is 12. Anion gap calculated minus 12 upon 24. 24 is the average of the normal bicarbonate minus the bicarbonate that is given in the question. So if we find out the delta ratio, then the normal range is in between 1 to 2. And if in the question the delta ratio is coming out in between 1 to 2, it means that you are dealing only with high anion gap metabolic acidosis. But if in the question the delta ratio comes out to be less than 1, it means that the delta ratio is less than 1, it means that the denominator is high. The denominator is high, it means that the bicarbonate is low, isn't it? The bicarbonate is very low. So along with high anion gap metabolic acidosis, there is some other source of acidosis as well, and that is the normal anion gap acidosis, metabolic acidosis. So if it is, the delta ratio is less than 1, and if the delta ratio is greater than 2, it means that the bicarbonate is high, isn't it? So along with this high anion gap metabolic acidosis, there is also a component of metabolic alkalosis. This is what we mean by delta ratio greater than 2. So these are the steps for calculating and interpreting the ABG. So with this, thank you for watching, and for more videos do subscribe to this channel, and for any suggestions or any queries you can always comment it down in the comment section. Thank you.